So today's lesson is I can describe and sketch qualitative graphs. So we've been talking a lot about graphs the last few weeks, but now we're talking about qualitative. So let's talk about what qualitative means. This graph shows a qualitative graph. Qualitative graphs are graphs used to represent situations that may not have numerical values in the graphs or that they're not included. So you have an axis like you have with all the others, but there are no numbers. So it is more of a generalization about what is happening, and the numbers don't matter as much. So you can see the axes are labeled, but they don't include the numerical values. So this, the x, is time, and the y is the percent downloaded. And so you can see the relationship between the time and the amount downloaded. So you have to think logically about what this tells us about the graph. So if you think about it, we can see that the time, the percent being downloaded over time, is raising at a constant speed, and then it kind of gets stuck, and then it's increasing even at a greater speed, but it's still constant, and then it gets stuck, and then even more, but is more similar to the constant speed at first. So linear increasing at a greater rate, linear increasing. And then this is when it was stuck, where it wasn't downloading at all. All right, let's do some practice problems. This graph shows the bathtub, the water level of a bathtub over time. So one of the things that you're going to be expected to do on your assignment is describe the change. Tell me what is happening. Tell me a story. So this is where writing comes into math. You're telling me a story about what this graph shows. So here we can see that it's increasing, and then it's steady, and then it's decreasing. So what might that tell us? So take a moment, pause the video, and tell me in words what you think this story might be. So what is happening to the water level? Don't just say it's increasing at a constant rate, then no change in decreasing. Put it into a bathtub story. What is happening to the water level? So pause the video now, please. Okay, so one might write this story. When the time was 0, so right here, the water in the bathtub was 0, so the water level was 0. The water level in the bathtub increased. You're making very specific. You're not saying it, and you're not using that word it. The water level in the bathtub increased at a constant rate. We know it's a constant rate because it's going up, so the slope is the same, so the same rate. Then the water is turned off and the water level does not change. Then the plug is pulled and the water level decreases at a constant rate until the water level is 0. For the third example, let's do the opposite. I'm going to give you the story, and then you need to pause and write out what it means. So what the picture would look like. So a tennis ball is dropped onto the floor. So picture this in your head. Tennis ball is dropped onto the floor. At each successive bounce, it rebounds to a height less than its previous bounce height until it comes to a rest on the floor. So you need to graph this over time, distance from the floor. So what is happening? This is over time, distance from the floor. In other words, picture in your head what those bounces might look like. Again, please pause the video and try to do this on your own before restarting. Okay, so this is one example of what you might have drawn. So the distance from the floor starts out at a high value, and it falls to the floor, so not at a constant rate. Then it bounces up to a height that's a little bit less, and back down, and a little bit less, and back down, and a little bit less every time. Most common mistake that I have seen on this is doing V's like this. This might be is like a basketball going straight up, you hit it and it goes straight back down. Straight up, you hit it and it goes straight back down. But this was more of a gradual bounce with an arc versus a sudden stop and back down. So this one would not work. And notice also here, a lot of people start down here, but we're starting up high and bouncing it. So those are the two most common mistakes on that one. All right, let's go back to example 2 because we just did example 3. Example 2 is, again, I'm giving you the graph and you need to figure out how to describe it. So the graph shows the temperature throughout the day. So describe the change in the temperature over time. So pause, see if you can figure it out, and then restart. So when you're describing a graph, remember first it has to be specific to the story. Second, you're talking about whether it is an increasing or decreasing at a constant rate or not a constant rate. Remember, if it is linear, it's at a constant rate. So linear is a constant rate. And nonlinear is not a constant rate. So here this is clearly increasing. So it starts out and it's increasing not at a constant rate. So we could say over time the temperature increases not at a constant rate until it reaches a maximum, and then the temperature decreases at a rate that is not constant. Now, I personally don't like this because it looks like it's starting out at 0. So maybe this was a really cold day and it was 0 degrees and then it went up. We've had lots of those days where it starts out at 0 and goes up to a certain amount and comes back down at night. So maybe that is a situation. But again, increasing, decreasing, not at a constant rate, at a constant rate. Those are the important things. All right, last example. This is like the second example on this video, but the third example on your paper. This is where you need to draw out the graph given this situation. So Tamara rides her bike at a steady rate. So remember, steady, that's making me think that it's constant. And then she coasts downhill, which increases her speed at increasing rates. Now this one is tricky because you really have to pay attention, as always, to the axes. So we're going over time, but we're not talking about distance. We're not talking about distance from wherever she started. We're talking about her speed. We're talking about her speed. So pause this and see if you can figure out what this might look like. You can always correct it, but I want you to try this on your own first. Okay, so if we're talking speed, it says she's riding her bike at a constant rate. So that means that her speed is not changing. She's going at a constant rate, so the speed is not changing. So let's say she's going 10 miles per hour, 10 miles per hour. And then she starts going downhill. So her speed increases, but it doesn't increase at a steady rate, it increases at an increasing rate. So the picture might look something like this. Here she's going steady, 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 and then she starts going downhill and her speed gets faster and faster and faster and faster and faster. So it might look like something like that.